Hi class, today we are graphing quadratic functions in the form of y equals ax squared plus bx plus c, and we're also graphing quadratic inequalities. Now today is a little different than yesterday in that we now have a b value, so we have that middle term that we need to work with. It's not as easy as just shifting an x squared up or down based on where it's the vertex is. So we need to pay a little bit closer attention to some of the details. You're still going to look for that axis of symmetry. That's going to be that mirror that really helps us in our graphing. So the axis of symmetry is x equals negative b over 2a. So we're going to be looking for that. And then we find that value and we plug it back into our quadratic function in order to find the y value that matches up with it to make that point. And that is always going to be our vertex. Let's look at an example. So here we have the quadratic function y equals 2x squared plus 4x minus 3. So the first thing we need to do is find that axis of symmetry and then the coordinates of the vertex. So we look at where x equals negative b over 2a, and that is a negative sign there. And so we take our 4, which is the b value. Remember, here's our b value. Here's our a value, which is 2, and our c value is negative 3. So we take our b, which is 4, and we take our 2, which is the a value, and we plug it into this formula. And we get negative 4 over 2 times 2, which is 4. So we end up getting negative 1. The x-coordinate of the vertex is negative 1. It's also x equals negative 1 is our axis of symmetry. So we now plug in negative 1 into the original equation, the quadratic function there. And again, we have 2 times negative 1 squared. Gotta watch your signs with these, it's really important. And then times 4 times negative 1. And again, signs are important, minus 3. When we do all of the math here and compute that, we get negative 5. So we now have a vertex of negative 1, negative 5. That's our vertex. That's going to be either our maximum or minimum. Now, if you look at this equation here, because we have an a value that is a positive number, we know that's going to be the bottom point. That's the minimum because it's going to open up. So if you think about that on our graph, what I've done here is I've kind of drawn this dotted line. I hope you can see that in the video here. I've drawn this dotted line as our axis of symmetry. Then I've plotted our vertex, which is right here. Now I need to find 2 other points. So I pick any 2 numbers. Pick numbers that are very easy to compute. Okay? Pick 2 numbers that you can work with. 0 is a great one to plug into the equation. It helps, to do some quick math. You can do probably the math in your head, and you get that the y-coordinate when x is 0 is going to be negative 3. So 0, negative 3, and here I've plotted it in purple. Then I pick 1. Again, an easy value for my graph. I plot 1, or pick 1, and my y value then becomes 3. So here's my third point. Now imagine here's my parabola. It's opening up and it's going up just like that. Now wait a minute, I've only shown you half of it. Remember this, we talked about this as a mirror. If you look at this point here, you know that you're going to have a point right here that's going to be exactly 1 space away, because this is 1 space away. In this case, this point up here is 2 spaces away. So if I count over 1, 2, I get that second point. And you can check this doing the math. If you plugged in negative 2 in for your y value, or in for your x value, you would get negative 3 for your y value. And if you plugged in negative 3 for your x value, guess what you're going to get for your y value? Positive 3. So here we can see the other half of our graph. You can also check these points by plugging in your equation into your graphing calculator. Okay, right, plug that in, go to your table of values, and hopefully you'll see that you can see those points there. All right, so that's how you graph a parabola, and I always recommend at least 5 points when you're graphing a parabola. It just helps take shape. 2 on the left side, 2 on the right side, and always plot that vertex. Let's try another graphing situation here. We're going to graph a parabola, but this time we've got not an equal sign, we've got an inequality. Think back to your inequality graphing days, not too far in the past, but think about open circles, closed circles, dotted lines, solid lines, and then shading above or below. Those are all of those questions you're going to have to ask yourself as you start graphing. Let's look at quick check or example number 2 here. So now we're graphing this quadratic equation. Y is greater than negative x squared plus 6x minus 5. Okay, so the first thing you want to do is you want to graph the equation y equals negative x squared plus 6x minus 5. And so I found my axis of symmetry by using negative b over 2a, okay, is going to give me positive 3. So x is 3. Then I plug 3 back into my equation here, and I get 4 for my y value. That's going to be my vertex. So there you see I've plotted my vertex in purple. Now in this case, because it's a negative a value, remember it's going to be a maximum point and it's going to open down. So we're going to have that point that's going to be the tippy top of our parabola. And then I've found 2 other points by using 1 and 0. Again, those easy numbers are going to be helpful. So I plot those points, and then I'm also going to plot their mirror images by counting over and plotting those. And I have this here, and I go 1, 2, 3. Here we go. And I can see the parabola. Now I'm going to make this line a dotted line, because notice it's equal, or it's not equal, it is, and I'm having a hard time drawing this dotted line, I apologize. It is a, it's just a greater than symbol, okay? So if it were greater than or equal to, then I could use a solid line, but because I don't have that underline underneath my parabola, or in my inequality, my line that my boundary line for my parabola is going to have to be dotted. Notice here, greater than. Okay, now we have to think about where y is greater. Where is y greater? On this case, is y greater on the outside of the parabola, or is y greater on the inside of the parabola? Usually when the parabola opens down like this, the greater is going to be on the outside, and then less than would be on the inside. If the parabola opened up, then the greater is going to be on the inside, and the outside will be the less than. But in this case, we can see here y is greater up here. So we are going to shade in all of our outside the parabola here, and that's going to be the solution. And then I'm going to make it look, I know it's going to look like an amoeba here, but you can kind of get the picture. So the outside of this parabola is where our solution would be. Okay, and guess what? Your graphing calculator will do this for you too. Just remember, greater than is going to be the top half, and less than will be the bottom half, changing that equal sign in your graphing calculator. Good luck. Go ahead and do the quick checks, make a sketch, and compare it with your table mates in class today. Thank you.